Hey everyone, in this video we are going to learn how to use the distance formula to find the distance between 2 points on a coordinate plane. So we're going to come back and talk about these two in a little bit. Let's first go to what the distance formula is. So the distance formula is d for distance equals the square root, and I'll write that in after I have everything under it, of x2 minus x1 squared plus y2 minus y1 squared. Okay, all of that under a square root. Okay, so we are going to find the approximate length of a segment RS, which means the distance from R to S, given these two endpoints. Here it is on a graph. Now, if it was vertical or horizontal, I would just be able to count. But since it is diagonal, I can't just count that length. I need to use this distance formula. So the distance formula tells me that D equals, or I could write this, the length of segment RS equals, then I'm going to have x minus x, so 2 minus 4 squared, plus y minus y, 3 minus negative 1 squared. Okay, and then I'm going to take the square root. Okay, so 2 minus 4, that's negative 2 squared, plus 3 minus negative 1. Minus negative means plus, so 3 plus 1 is 4 squared. And still under a square root. So negative 2 squared, that's 4. 4 squared is 16. So that is the square root of 20. Okay, so we're finding the approximate square root. So I'm going to type into my calculator the square root of 20. Okay, so square root is this right here, but I need to hit second first. So second square root of 20, and I get 4.47, and that looks like it's going to round to 4.5, so it is option C here. Now in that example, would it have mattered which point I chose for x1, y1 and x2, y2? So does it matter, in other words, if I did 2 minus 4 or 4 minus 2? And the answer is no, it doesn't matter. And that is because when I square, it's going to come out positive anyways. So the real issue is that this number, whether it's a 2 or a positive 2, 2 or negative 2, 2 minus 4 is negative. If I had these turned around, 4 minus 2 would have been positive. But they have the same absolute value. And when I square them, they end up the same. So no, because absolute value would be the same. Okay? Our next question, we're going to find an exact length. And in order to do that, first, let's practice simplifying some radicals. Okay, so the square root of 110. So 110, I can break that down into, say, 55 times 2. And 55, I could say, is 11 times 5. So I have an 11, a 5, and a 2. Those are my prime factors. Nothing comes in pairs. That means that all three of those, 11, 5, and 2, stay inside. And when I multiply 11 times 5 times 2, I get 110. So it looks like the square root of 110 actually does not simplify at all. Okay, so sometimes a square root is its own simplest form. How about 1,260? Well, that's 10 times 126. 10 is 5 times 2. 126, if I add those three digits, 6 plus 2 plus 1, that makes 9. And 9 is divisible by 9. So I know 9 is going to go into 126. Let's just see how many times. 126 divided by 9 is 14. 9 is 3 times 3, and 14 is 2 times 7. I have a pair of 3s. I also have, even though they're not next to each other, a pair of 2s. So that means a 3 will come outside the radical and a 2 will come outside the radical. And the leftovers are 5 and 7. Okay, so I've got 5 times 7 inside, so that is 6 times the square root of 35. Okay, so that is the simplest form of the square root of 1,260. So when we do exact answers, when we use the distance formula, we're going to have a radical like we did up here, but we'll simplify it like we did up here. An approximate answer has a decimal. It's in this case because it's approximate because we rounded it. Okay, sometimes we can take a square root, like let's say we get the square root of 16 and it's 4. There's no rounding involved. That's an exact number. But if I have to round, then it's an approximate answer. Okay, when we do this, we will never round, so that will always be exact. Okay, the exact length of segment AB. So the length of segment AB is x minus x, negative 3 minus 1 squared, plus y minus y, 2 minus negative 4 squared, all under a square root. Okay, so that is the square root of negative 3 minus 1 is negative 4 squared, plus 2 minus negative 4, that's 2 plus 4, 6 squared. Okay, so we've got the square root of 16 plus 36, and 16 plus 36 is 52. So we have the square root of 52. Now if I just type that in my calculator and get a decimal, that will be an approximate answer, but I want an exact answer. So I'm going to do a factor tree. 52 is 26 times 2. 26 is 13 times 2. And those are all prime. There's a pair of 2's. A 2 comes out. A 13 stays in. And that is my exact answer.